Okay, here we go. My first video, let's see what happens. First of all, this is the 20.2b assignment, and of course, you would always write that in the top right corner of your paper. If you haven't done that yet, do so. I'm going to work a few of these problems from this section. Hopefully, you've already looked through either my typed notes or Mrs. Franken's video on the notes on this topic. But here we go. I'm going to look first at number 3. We're talking about a college entrance exam is designed so the scores are normally distributed with a mean of 500 and a standard deviation of 100. I'm going to fill in the curve before I even look at any of these questions. Let's take it over here. The mean was 500, and the mean always goes in the center. And the standard deviation is 100. Standard deviation jumps us up for each space here. Plus 100 gives me 600. And again, plus 100 gives me 700. Plus 100 gives me 800. And I need to go backwards, minus 1 stabbing to deviation each time. So I'm going to take this 500, I'm going to subtract 100, take me down to 400, minus 100 takes me to 300, minus 100 takes me to 200. These are the numbers I call my x numbers, and these are the numbers I call my z numbers. Z's, x's. The x's are the number they ask you about in the problem. The z's are the numbers that go with the curve that we use to standardize it so we can use all these percents. Let's go back and see what kind of problem we actually have to deal with. I'm going to look at number 3 first. What's the probability that a randomly chosen exam score is above 600? This is our x value given in the problem. X value. Above 600, greater than 600. I need the z that goes with it. Let me look what I just wrote on the curve. The z that goes with 600 is right here. Positive 1. Let's take it back here. Change this to z is greater than positive 1. I'm going to use the curve to figure out what percent of the curve is actually greater than positive 1. Greater than means go to the right from the positive 1 on the curve. Greater than tells me I'm going right. Less than tells me I'm going left. So I have 600, and I need to go to the right from the 600. And this is my 600 line. I'm going to use this percent, this one, add all of those things up. Take it back. 13 point, ooh, let's change that to a better pen. 13.5 plus 2.35 plus 0.15. That all works out to 16%. Unfortunately for this assignment, I've asked you to work each of these problems out 2 ways. So this one, using that curve, we're going to call that our A answer. And then we're going to come over here and work on our B answer. We're still dealing with x greater than 60. We're still dealing with z greater than positive 1. We're going to go to the table. In the left-hand column, we're looking for z equals 1. Pass the curve. That's the negative side of the table. We need the positive side of the table. Keep on going. Positive side of the table. Here's our 1.0. I need to remember this number. 0.8413. Zero. 0.8413 even if I change that into a percent, 84.13%, not even close. Not even close. That's because the table tells us less than, we want greater than. So I'm going to take 100% minus 84.13%, and I'm going to get 15.87%. Having troubles with writing a decimal on this thing. 15.87%. Close, but not perfect. That happens because the table's actually a little more accurate than the numbers we have memorized in our curve. We're going to call this one our B answer. Okay, let's work on number 4. Number 4 is kind of two problems at once. I can't say between, but it does deal with two of the x numbers. What's the probability that a randomly chosen exam score is less than 300 or greater than 700? That's not between. That's kind of outside of those two numbers. We got to figure out the z's that go with that. Let's go to the next page and look at our z values. Notice I put in these other percents on the bottom. Those are also percents that you kind of need to know in order to do this, but you could get it just from the top. So we're looking at things that are greater than 700. That's out here in this area. We're talking about the numbers that are less than 300. One way to look at that is z values, looking at the z's. Z's for 200. Okay? Positive 2 and negative 2. And take them off of there so that they won't be in my way when I come back to it. This is talking about z less than negative 2 or z greater than positive 2. Over here, we had 2.35, 2.35, 0.15 adds up to 2.5%. Same numbers here, but off the right-hand side. 2.35 plus 0.15, 2.5%. When they say they're happy with any number that is less than 300 or greater than 200, means I'm actually going to have to add those. And I think this is the only problem in this assignment where we end up doing not just less than, not just greater than, not between, but to the outer edges. This turns out to be 5%. Now let's go back to that curve and let me show you a different way to look at this. A different way to look at this would be saying from negative 2 to positive 2 is 95%. A whole thing, if we went out to infinity, would be 100%. An alternate way to get there would be to say 100% minus the 95% in that middle section, and I'd still get 5%. Same answer, different way of thinking. I don't care which way you are working it out, but you got to show me what you're doing. I need something to show your thought process. On each of these problems, I expect to see an inequality statement. You can do the inequality statement with the x's, with the z's. I always do both. And then also something that shows me how you got your percent. These two separate things added up works nicely. This right here, subtraction, works nicely. We going to call this our A answer, the one we did using the curve. We also need to work this thing out using the table method. I'm still dealing with the two different z deals. Z is less than -2. Z is greater than +2. So I'm going to my curve, looking for the -2 side first. We have a -2 right here, 0.0228. Point 0, 0, 2, 0.0228. 2.28%. If I go look up z equals +2, one more page till I get to the +2 page. Positive 2.9772. But you can see, if I try and just add those two together, not even close. This one's greater than. The table doesn't tell us greater than. I gotta do 1 minus 0.9772, which gives me that same thing we had over here, 0.0228. Or 2.28%. Now I can add this, and I end up with 4.56%. Close to my answer using the curve, but not quite the same, because again, it is just a little bit more accurate. We're going to call that the B answer. As you work through the rest of this assignment, I want you to make sure you're thinking about showing each problem two ways, once using the curve, once using the table. If the answers are turning out to be not very close to each other, it probably means you should have done a 1 minus in there somewhere. Or some people prefer to change this to a percent first and do 100% minus 97.72%. Yeah, it could be not perfect, but close. The only time you'll ever see these two methods giving you exactly the same answer is if you're right at 50%, which means right at the mean. In this case, the mean was 500. If they asked me a question about 500, I'd have that. Okay, end of this video. I'm going to work on another one.